In this video, I'll be explaining free radical substitution, the mechanism by which an alkane is converted to a haloalkane. So the conditions that are necessary are UV light, ultraviolet light, or 300 degrees Celsius can be used instead. And of course, we'll need a halogen, which for this example we'll use bromine. So, the equation. We'll start off with butane, C4H10, and we'll add Br2 to it. And for this example is a mono substitution. Therefore, only one hydrogen atom will be substituted for a bromine atom, and therefore this gives us C4H9Br, with the other hydrogen atom bonding with the bromine atom to make hydrobromic acid. For the next reaction, we'll also use butane, but this will be a triple substitution, with 3 hydrogen atoms being substituted for 3 bromine atoms. And this is going to make 3 moles of hydrobromic acid, and therefore we're going to have 3 moles of bromine. So now we have the mechanism, which has 3 steps, with the first being initiation. And in initiation, the Br2 is split up by homolytic fission, and this gives us 2 bromine radicals. And a radical is a species with 1 unpaired electron, making it very reactive. Now the second step in the mechanism is propagation, which has 2 equations, which we have to remember. So we'll start with butane like before, and from initiation we have the bromine radicals, and the bromine radical attacks the butane, and it takes away one of the hydrogen atoms, forming hydrobromic acid. And the carbon now only has 1 free electron, I missed that out, sorry, which makes it a radical, so we need to put a radical dot there. Now for the second equation, we use our C4H9 radical, and we add Br2 to this, and the C4H9 radical attacks the Br, splitting it up, forming C4H9Br, which is bromobutane, and then bromine radical is formed, and therefore, because it's regenerated at the end of the reaction, bromine radicals are a catalyst in this. Next we have termination, the third step in the mechanism, which also has 3 equations, which you must remember. We have the bromine radical plus the C4H9 radical, and this gives us bromobutane, which is what we want essentially. And then we have 2 bromine radicals adding together to create a bromine molecule, Br2. And then we have 2 C4H9 radicals adding together, which will create C8H18, which is octane.